Hello learners, in this lecture we will see how to prepare the load combinations, right? So for that I need to go to define, and in define there is option called load combinations. So in the load combination right now we don't have anything. So what I need to do, I need to go to option called add new combo. So now what is this load combination? See, whenever a building is put up, what all are the load that is acting? One is the dead load of that is the self weight of the beam, the columns, the slabs. Next is the SIDL load, that is the floor finishing load. And then we have the live load, right? So all these three loads will be acting, right? So when the building is in construction, only the dead load will be acted. Once all your building is put up, once you start with the finishing works, your SIDL load comes into play, and once everything is done, once the building is put to use, the human beings, that is a live load, is going to come. That means my building has to be designed for all these three loads, right? So I'll try to make a combination out of this. That is, I'll make use of a combination like dead load, SIDL, and live load. All the three loads will be acting here, right? So what I'm going to do, I'll delete this once again. Yeah. So I'll write it here combination one. For that, I'll write it as 1.5. I'll explain the significance of 1.5. Let me write it as dead load plus SIDL plus live load. I'll close the bracket. And now you can see the written here, and the scale factor is 1. You have to make this as 1.5. Now come to add here. Now the next, click here and say this will be my SIDL. Click on this SIDL. And now here also make it as 1.5. And now say add, and what is left out? Live load is left out, right? Click here and say live load and make this as 1.5. And that's it, done. All these things have been added, and say okay. Similarly, we have to make one more load combination, that is for dead load, live load, and SIDL. Again, I'll go to add new combo. So this time I'll not put 1.5, I'll just say 1. Okay, I'll open the bracket and I'll say dead load, I'll say live load, and I'll say SIDL, and I'll close the bracket. That's it. And now here let me add 3 load, and now dead load is 1. For this I'll make this as SIDL and let this be 1, and here let me make this as live load and let this be 1, right? I added it, so you can see 1.5 dead load plus SIDL plus L, and 1 dead load plus live load plus SIDL. Now the question is that why this 1 point has been added. See, whenever we design our structure, we design our structure for limit state of collapse. One is for the collapse, the second is for the serviceability, the second is for the serviceability. Okay, so what is this limit state of collapse? See, let us say I have a building here, let us say I have a slab here. Okay, and on this slab let us say 50 kg of a load is coming. So when I try to design this slab, I don't design my slab only for 50 kg, keeping future point of view. In future this slab may be subjected to some 60 or 65 kg of the load, right? I cannot predict that exactly. So as a structural engineer, I'll always go with something called as factor of safety. So what I'm going to do, I'll multiply this by 1.5, that is 50 into 1.5. How much it comes out to be? It comes out to be 75 kg, right? So whenever I design this slab, I'll design this slab for 75 kg. Let the load coming be 50 only, but I'll be designing this for 75 kg from keeping future point of view, right? So this is called as limit state of collapse. So that is why I added 1.5 here, and this 1.5 is for dead load, for SIDL, as well as for live load. Now coming to the another combination, what I've created is dead load plus live load plus SIDL. So the second load combination what I've created, that is for limit state of serviceability. That means let us say a 50 kg of load is coming. Okay, but when I design this, when I check it for limit state of serviceability, for this 50 kg of the load, there should not be deflection in my slab, isn't it? Let us say I'm putting a load here on this particular slab, and let us consider the load is some 100 kg. Okay, so when I put 100 kg of the load, I don't want my slab to deflect in this way, isn't it? I don't want my slab, I don't want my beam to deflect in this way. If it deflect in this way, what will happen? People will be scared to come inside the building. By looking at the deflection of the beam, they are scared to stay inside the home. So from serviceability point of view, from aesthetic point of view, what will happen? People will not come into this building. So whenever I apply load on the structure, the 100 kg load, I should make sure there is no deflection in my slab and there is no deflection in my beam. So this is called as limit state of serviceability. So here we are not going to put factor of safety of 1.5, because this 1.5 what we are putting, like let us, like I mentioned, 50 kg is a load, but I'll design it for 75 kg. But I don't know in future whether this 75 kg will come or not, but I'm taking from future point of view. But for limits of serviceability, this 100 kg is exact. This, let us, instead of this 100, no, I'll speak for 50 kg only. I took example as 50 kg. Let us say 50 kg of a load is coming. So this 50 kg of the load is going to come for sure. Once you put this building into use, 50 kg of the load is going to come sure. And for this 50 kg, I have to make sure there is no deflection, no. So that is the reason here we are not multiplying this by 1.5, we're taking it directly 50. Okay, so this is called as limit state of serviceability and limit state of collapse. So I'll delete this. So with this understanding, these are the two load combinations what I've created, and I'll say okay to this, right? So once these things are done, next is that we have to check our model to make sure whether we have done everything, the modeling what we have done is correct or not. Like sometimes what happen, you might not be, connected your beam properly at the junction point, your slab may be half drawn and all. So that is the reason I'll go to analyze, I'll say option called check model. So here what I'm going to do, I'll say select all objects. Okay, you'll select everything, the ETABS will check for everything and say okay to this. So ETABS will do the checking. It will make sure whether if you have any made any small error in modeling, it will give you a warning saying that there is a uh, error in your model. As of now, I can see model has been checked. No warning messages were created. That means whatever model I have done, it is good, and there is no error in that, right? So once this is done, next is that we have to run the analysis, right? So if you want to run the analysis, you can see a small option here. It's a run analysis. I'll click on this. So the moment I click on this, the ETABS will do all the structural analysis calculation. It will try to find out what is the bending moment coming, what is the shear force coming, what is the deflection happening in your building, how safe is the structure and all, right? Yeah, it's doing the analysis. Once the analysis is done, you can see the deflected shape of that, and you can see the model has been run. Now what I'm going to do, I'll design all these things. I'll make sure I'll ask the ETABS whether the size of the beam and the column what I've given, is it sufficient enough to take care of the load that is coming in the structure or not. So for that, I'll go to this option called as design. I'll go to the option called as concrete frame design, and here there's option called start design check. Click on that. Okay, it will go. So ETABS is checking everything. Okay, so what I'm going to do, I'll click here, I'll go to option called design, concrete frame design, and let us do this start design check. Okay, so what has happened, it has done the checking, and after checking it has been found that, let me go back, it has been found that for this particular building what I've created, the column sizes what I've given, no, the one which is pink in color, that means your columns are passed, your column is sufficient to take care of the load. But whereas here the columns are red in color, that means your columns have failed. That means these columns and these columns are not sufficient to take care of the load that is coming on this building. Here everywhere it is red, the columns are also red, and you can see the beams are also red in color. That means this particular size of the beams and columns what we have given, your building is not sufficient enough to take care of that. So what I need to do, the only option what I have is to change the size of it. And why is that? In the story for everything is passing, if it is green in color, that means your beams are passed. If your columns are pink in color, that means your columns are passed. Now why is that in the story 4 your columns and beams are passing? Because in the story 4 you don't have any load coming, right? You have only the wall load on this beam, and you don't have any load on your on your floor. That is the reason your columns are passing. But whereas in the ground floor, if you go to the ground floor, you can see all the story, that is the story 4, story 3, story, all the loads are coming on this particular uh, columns. That is the reason it's failing here. So how do you change all these things? If you want to change all these things, you have to change the size of your column. Whatever size of your column you are given, that is not sufficient to take care of the load. You have to change the size of the column. So for that, what I'm going to do, I'll unlock the model. Okay, and once I unlock the model, what I'm going to do, I'll go to this option called select. I'll go to the option called define. I'll go to option called section property and frame section. Now whatever size you have given, no, we'll try to increase the size of that. The beam, the column what we had given was 230 by 300. So instead of 230 by 300, I'll make use of a column of 230 by 450. So I'll click on this. I'll go to modify or show property. Okay, and this time instead of 300, let me increase the size of the column, right? I'll make it as 450, 450, And here also this is for our naming, you have to actually change here, only then the ETABS will understand you have changed the column size. You have to input 450 here and say okay to this. And also let us say the beam size also is not 230 by 300. I'll modify that. Let me give a beam size of 230 by 380 mm. 380 mm comes out to be 15 inches, 9 inch by 15 inch. So I'll give this as 380 mm. And here also let me make this as 380 mm. Okay, yeah, and that's it. I'll say okay to this, and now I'll say okay. And now let me run the model again. I'll go to this option, run analysis. And now if we will check whether our building is safe enough to take care of the load for the dimensions what I've given. Yeah, so model is locked, analysis is done. Go to design, concrete frame design, and start design check. So again, few of my beams are okay. Let me do it here. Design, concrete frame design, start design check. Yeah, so if I go to the story one, all my columns are passing, but again this beam is failing. You can see this beam is failing. Similarly, if I come to the story two, all my columns are passing, but these beams are failing. Similarly, if I come here, again all my columns are passing, but this beam is failing. Similarly, if I go to story 4, everything is passing here. So again, what has happened, the beam size what we have given, no, again that is not sufficient enough to take care of the load that is coming, right? But now what we have to do, now again we have to change the size of this beam, isn't it? Again we have to change the size of this beam. But before we try to change the size of this beam, let me tell you one small concept here. Okay, so the concept is that we have a beam here, right? So these are my secondary beam. See, let me explain. There are two kinds of beam. One is a primary beam, the second is a secondary beam. Yeah, so these primary beams are those beams which are connected from column to column. You can see one column here, you can see another column here. So there is a beam here, right? So this becomes my primary beam. Similarly, you have a beam here, you have a column here, you have a column here. You connected a beam. So this becomes my primary beam. Now let me delete all these things. Now you can see a beam here. What has happened with this beam? This beam is sitting on this beam, and also this beam is sitting on this beam. So this beam is called as my secondary beam. It's called as secondary beam. Similarly, look at this particular beam. This beam is sitting on this beam, and also it is sitting on this beam. So again, this is a secondary beam. So always remember the secondary beam what we have to make them as simply supported beam. Okay, we have to make this a simply supported beam. That means if I try to draw, see, first I'll draw the bending moment diagram. That is bending moment diagram for the simply supported beam. This is my beam. So when I draw the bending moment of my simply supported, this is how the bending of a beam will happen, right? So this is my maximum bending moment, which is WL square by 8, and here the bending moment near the support, right? It will be 0 here and it will be 0 here, right? And now if I draw the bending moment for the fixed beam, let me draw it here. So this is my fixed beam, right? This is how we used to do it in the manual calculation. This is my fixed beam, right? And how the bending moment of a fixed beam will happen, we'll be having a negative, we'll be having a, let me do, give me a minute. Yeah, you'll be having a negative bending moment here, then you'll be having a positive bending moment here, and you'll be having a negative bending moment here. This is negative, you'll be having a positive bending moment, you'll be having a negative bending moment, right? So this is a behavior of a fixed beam and a simply supported beam, right? So now this beam is my, let me delete everything. So this beam is my fixed beam because there's a column here. This is also my fixed beam, this is also column here, but this is my secondary beam. Now how should the behavior of this beam should happen? So it should have a negative bending moment, it should have a sagging bending moment, and it should have a negative bending moment. Similarly, this beam what I have, it should have a negative bending moment, a positive bending moment, and a negative bending moment, right? And this beam is called a secondary beam. So the behavior of the beam should be in this way, isn't it? This is how the behavior of a beam should happen. There's a maximum bending moment at the center. Now we'll try to see the bending moment of the beam of what the analysis we have done. So for that, what I need to do, I'll click here. You can see option here. It's written display frame, pier, spandrel, or link forces. I'll click on that, and there is something written here moment 33, and I'll check for that combination of 1.5 dead load plus live load plus this load only I have to check. I'll click on M33 and I'll select on this. Now try to see the bending moment what I've created. Okay. So whatever I explained you, the same bending moment you can see it here. Let me click on this beam and right click. So what has happened? You have a negative bending moment here, right? You have a positive bending moment here. You have a negative here, right? See, try to see it. So this is how it is, right? Similarly, if I try to see the bending moment here, again right click here, again what you can see, you have a negative bending moment at the support, then you have this positive bending moment, and then you have a negative bending moment. It's good. But if I look into the secondary beam here, if I right click on that, what is the behavior of the beam? Even this secondary beam what we have, no, it is behaving like a fixed beam. That means I'm getting a negative bending moment, negative bending moment, and a positive bending moment. But according to our theory, whatever I explained you, the behavior of this beam should be something like this. That is, it should behave in this way, right? It should behave in this way. But now what is happening, it's getting a kind of, it's behaving in this way. It's having a negative bending moment, positive and negative in this way. That means these beams what we have, they are designed as a fixed beam, but we want to make them as a secondary beam. So what I'm gonna do, so I'll try to release that moment. So that is called as moment release. I'll unlock the model now. Okay. And wherever I have secondary beam, I'll try to release that. Okay. So again, I'll say all stories. I'll select this beam. Okay, this is my secondary beam. Similarly, this is also my secondary beam, and similarly this is also my secondary beam. I'll select all these three beams. I'll go to option called assign. Okay, and then I'll go to option called frame, and then I'll go to option called release or partial fixity. I'll click on that. Now here there is an option called moment 33, right? I'll click on both this and I'll say apply to that. So now can you see something has assigned here? That means these beams will be acting like a simply supported beam now. That means whatever fixed end moments we were getting here, no, that has been released and that is made, and this beam is made to behave like a simply supported beam. Now let me try to run this analysis and we'll check how is the behavior of this beam. Yeah. Now I'll go to design, concrete frame design, and start design check. Yeah. Now can you see that what has happened? Everywhere your beams are passing. Why is that? Because okay, anyway, I'll show you the this thing also, the bending moment of that. I'll click on this now and I'll say combi 1 point apply. Now let me right click on this beam. Okay, now can you see how is the behavior of this beam? It is behaving like a simply supported beam. I wanted this to behave like a simply supported, that is why it's trying to behave like a simply supported. Same with this beam as well. You can see it's behaving like a simply supported, zero bending moment, zero, and maximum at the center. Similarly with this as well, right? Right? Yeah. But whereas these are fixed only, I did not release the moment. And because by doing that, what has happened now? By doing that, what has happened? The beams which were failing, no, now they all have passed, isn't it? Let me do that design, concrete frame design, and start design check. Try to see that. See, all the beams are green in color. Before what used to happen? They were green in, they were red in color. They were failing. But for the same size, since I made these beams as secondary beam, what has happened? These beams are passing, right? So in this way you have to do the analysis of your building, and whenever you feel the beams are failing, then what you need to do, you need to release this moments. Again, there is a lot of concept to all these things. It's not that always you have to release that. There are a lot of concepts, so those things we'll try to tell you at the end of the lecture, how you can learn all those things in a better way. Yeah. That's it. And similar, these are for the beams what I'm saying. Similarly, yeah, this is a bending moment what we have seen for the beams. In the next lecture we'll try to see the importance of all these things what I'm seeing here: 642, 321, 161, 832, 586, 280, yeah, 288. In the same way, if I click on the columns, I'll select one column and I'll right click on that, show selected object only, and I'll put this in the 3D format. So this is a column here, and in this column how much reinforcement is coming. For that I go to what I need to do. Yeah, you can see some area is coming here. It is 1646. So 1646 mm square of a steel is required in this particular column. So in this way we have to take each and every beam and column, and based on that we have to do the detailing of this particular structure. Okay, in the next lecture I'll be explaining you how these values have to be understood. and then we'll try to design one particular beam, and we'll try to detail this particular beam. So I hope these things are understood up to here. We'll see you back in the next lecture. Thank you.